let's talk about some legacy C issues, and one of the first legacy C things that C++ or modern day C++ programmers might be taken aback by. Taken aback by? Yeah, whatever. Yeah, close enough. Is this duplicate data? Duplicate data is usually no problem. Occasionally it can result in a problem that'll take a lot of man hours to find. So let's show a couple of examples where we have the error and it's actually two different definitions, and yet we've allowed one to override the other. Maybe you want to do this intentionally, but usually it's, usually, literally 100% of the time, no one has set out to do something so obscure as to have two different definitions in the same project and let one override the other. So let's do a couple of examples using Hello World, and we'll start there. All right, so this is a legacy C issue, duplicate data. It's generally a bad thing. I hate it. But if we get rid of it, we're literally changing code. I guess we could add compiler options to hide it, but that literally seems worse than actually leaving the warnings there. Okay, so let's show some examples. We'll start with the hello world. That's what we're gonna do here. Let me let you follow along. We're gonna start with the hello world. Let's introduce the hello world. We're gonna show you. It'll use a C file, H file. We'll use a compile via shell script. Just something simple, no errors or anything. We're flying through this. This is not a big deal. Okay, so let's give an example where we duplicate the data, and we have two source files, and the data is different. So we'll let one override two. You'll basically see this because one comes before two. How did we actually allow that? Well, we have this allow multiple definition. We're using this X linker. We're using GCC. That's how we did it. We're printing out a size of, in one file we have a size of 13 for the variable HW string. And in the other file we have 26. So yes, we are talking about an error or a horrible, horrible programmer if anyone did this intentionally. So we're going to allow one to override, and so we'll get the hello world. There's our one file. There's what's defined in hello world 1. And then we'll repeat the example and flip it. We'll let the other one override. And so we're basically going to switch 1 with 2. Yeah, might as well see it. Let's see it. And then we're going to duplicate the data with a library. So this is a scenario where C actually still has in the definition that the library can be overridden. It is again a very weird thing. There's an option to actually go through the whole library, make sure you don't have any duplicate data. We'll just illustrate that really quick. Then we're going to show the legacy code that generally causes this problem. and we'll do that with data. And then, just really quick, duplicate functions. Well, it turns out functions and data are duplicated for the same reason. No big deal. They're probably defined in the headers. And then we'll talk about these files that help us resolve these problems if they actually exist. These problems have consumed a lot of man hours when they crop up, but it's pretty rare that they crop up, especially in legacy code. You're probably not going to see them. Alright, so let's start at the beginning. Let's introduce our hello world. CDA. Hello world. .c. And here we have it. We have our includes. We have an include which defines our HW string, just, to allow other processes to use it. Our get size 1 here is a local function because we have the static here. We're actually going to return the unsigned HW string. This might seem incredibly trivial, but there's a reason to put it this way, and that we're trying to illustrate the problems. And then we're going to have a test function right here, which will just print out, the size and the string. And we're going to use this %u, and to make any code tool like Fortify happy, we'll use this %.256s. There's going to be an end to it. HW string. So your main just calls test, and that's it. That's the beginning and the end. That's hello world. That's what we're using. It could be simpler, but we're trying to go in a direction where we're going to show something else. Here's my compile line. I'm going to go ahead and save the temps. So I'll save the .i, I'll save the .s. Sometimes those are .ii. We can go over those in a different video. This is a debugging option in case we wanted to debug. This is our output, HWA, and there's our source, and so it's pretty dumb. So compile, beginning and the end, we said we put it in HWA, and there we have it. We printed out our size and hello world. Exactly what I said it'd do. Wow, it's like I planned it. Okay, now let's look at an example where we actually are going to take two files, hello world1.c and hello world2.c. Here they are, hello1, hello2. So what we're going to do is we're going to have one definition override the other. So if we look at our plan here, so then for our example, we're going to duplicate the data. Hello world 1 is going to have hello world 1. Hello world 2 is going to have hello world and elsewhere. We're going to have a compile. We're going to have output. So in the 1, the size will be 13. In the other, it'll be 26. These are in the object files, hello world 1.0, hello world 2.0. But when they're compiled and resolved, there's only one HW string. And so again, what we're doing is we're illustrating a problem with duplicate data. This is just really quick, really quick. We have a linker option, basically to allow the multiple definitions so we can show the legacy issue. We're going to let Hello World 1 override Hello World 2. And so in that case, we'll see that the Hello World 1 string appears because after it's been linked, that's what we have. But the size of is actually resolved during compile when we're building the object, and so we have two different definitions, one in each file. So if we go over to B, so if I put this in a shell script, cat c1.sh, we'll see that exactly what I said it'd be. We have an output HW1, we have a linker option, allow multiple definition, because modern compilers don't want to allow this. It's only the legacy C that really has a problem. So we compile it, we have our executable HW1. As we said, we have the 13, the 26, those are the size ofs. Regardless of which C file we print Hello World from, we get the same, or HW World, we get the same result. VI Hello World. And then this is what that looks like. So here's our HW string. Again, we put this into a function, like I said, because we're trying to illustrate more or less the silliness of it all. And here's our printf and our test. So there's print get size 1, which is right here. Get size 2, which is in the other file. And HW string, which will be set pretty much at link time because there's a conflict. And then I will jump to the other file, the other source file, to print it just to prove a point that in both files, even though the object file saved it in one way, when it was linked, it just only went with one choice. And so that's what we have. Let's go next. Here's HW2. So in this file, we have HW string as hello world and elsewhere. Then we'll print out the size through this function, and then we'll print it out like we said, and that's all. That's all it is. And, again, you see the result. The size of is resolved at compile time. These are really difficult. These are examples of really difficult to find bugs that are in Legacy C because the duplicate definition is not the same. You do not want different duplicate definitions. Alright, so let's here we have Hello World 1. That overrode the other one. But let's do something just to show we can, because we're illustrating a problem. Let's copy that. This is just a shell script, so we'll put that there. Let's change that to 2. Let's change that to 1. So at this point, before we actually compile that in a different order, we have hello world as the resolved duplicate definition. Now if we change it, if we do it again, we've changed the order. What comes out is hello world and elsewhere. So we actually now are using hello world too. So this is just an example of the dangers of not resolving your duplicate definitions. Don't do this. Okay, so again, let's go back to our plan. So we did A, we did B, we did C. Alright, well, we still have duplicate. We can duplicate the data with a library, and this is getting really weird because C still hasn't changed the definition of what should happen. Believe it or not, when we do here, I'll do a cat in lib.c. The only thing in the library is the HW string. Only thing. That's all we're going to put in there. And then we're going to have the pretty similar to what you've seen before in lib or use lib. Yeah, this will be a similar named function. Pretty much standard O, standard lib, HW string. We're going to define it as hello world, which is, you know, we have two different definitions. One in the library, one in the source. Which one wins? Most people know the library doesn't win. So the hello world overrides whatever you have outside the library overrides the library. And even weirder is that in the first two examples we had to have a special compiler option to avoid error, to avoid the whole thing from stopping. But with this library override, this is the definition of C. So it seems sort of weird that it just chooses one over the other. So I have a compile which just does a GCC, builds the archive. So I did that. Okay, fine. I also have a compile 2 where I build the executable. Again, I just build the executable, use and link with the library. Just to see if you guys are paying attention, I'll use a little bit more shell scripting, trivially more shell scripting. Check the return value right there, that's all. Compile 2.sh. Whoops. Compile 2, no sh. Okay, so we compiled the binary as a.out. Again, it's weird that it didn't stop you. There's no special compiler option. It seems weird where one way it's going to stop you and say no, and another way it's going to allow you to go forward. This is a definition of C. It allows the object files to override the library. So, but there is actually an option to let you know that you should scan the whole library. So if I build it that way, using this whole archive, scan the whole archive, let me know if there's any duplicates. I don't want to keep this option set for other libraries. I just want it on this one. That's it. Let's see, again, just having a return value and all that. Okay, so if I do that, compile to whole, what I have is I have something that will not compile, and maybe I want to know when there are duplicate data definitions or duplicate function definitions, and that's what I get. So I did that. I actually use this whole archive in the library against the library, and I got my multiple definition error of HW string. It didn't compile. That's awesome. It returns 0. All right. So, well, that's interesting. So there's a library, which will not give us the error. There's also the duplicate object files, which will give us an error. Welcome to C. But let's talk about where this came from. Where did it? Why does this Legacy C have it? So we have a Hello World 1, a Hello World 2. In this case, they're sharing this header file, and so, well, if I type it right. Now I misspell it. Alright, so I have my HW string, and this is in the header file. Oh, yeah, it's just awful, awful. Someone put data in the header file, so then when you build the first C file, you have an object file with data, and same with the second one. It's bad. It's not a good thing. We're just showing where it came from. This is not today's standards. It's bad form today. And so, but in Legacy C, this is what happened, where it wound up as a definition in the header file in one way or another. And you define these functions here. There's an extern. Anymore, I don't even think you need the extern. They're extern by default. I've defined, just via comment, which one's in the first file, which one's in the second file. That's all. And then, here we go. So we have a GCC here, same thing. We have an output file. We have the option to allow the duplicate definitions, because this is Legacy C. And then we decided to put one before the other. But in this case, they're both the same. I'm just showing that it's in the header file. This is where the duplicate definition comes from in Legacy C. And so when I build that, I get this HW1. When I execute it, I see that it's all the same. It's the same size of in both files, and the same object, the same definition in both of them. All right. Thank you very much. We'll talk about the I files and the S files in another video. If you wanted to see another way or other ways you could actually pursue any glitches you have with this Legacy C problem. All right. Thank you. Have a good day. Bye.